It says it'll start soon. Okay, so once you're completely done with the opener, go into Canvas, this Unit 4 test review. I'm going to do this actually with my Word document along with you. The Microsoft Ink seems to be working. I may have to recalibrate my board. I don't know if I did that since the last time that the projector reset itself. But we do have a test tomorrow. Now, I did find out, okay, ASVAB is going on tomorrow too. So it's my fault for not reading the Hornet highlighter, I think. But if you are taking the ASVAB, I had questions. If you're remote and you're taking it, what do you do? I think the counselors like personally sent those of you that were remote instructions. I think I deleted it. Here, ASVAB testing information. Those are study materials. You register, take the ASVAB. ASVAB on Friday. Says don't come to school if you feel sick. Duh. We've been saying that every single day. If you are quarantined, okay, this is applying to some of you that are remote. If you are quarantined, you are not allowed to test. I'm sorry. I know that my own niece could not take the PSAT because she was quarantined and she was not a happy camper. Let's see. I'm assuming if you are remote, okay, I'm not seeing anything otherwise because you guys are seeing my screen online too. It says you must wear a mask. You're coming, you gotta be at school by 8:15. You report to the PE gym. You're not allowed to have a smartwatch or anything. It will completely and totally null and void. This is a military test. They don't play.
I was gonna take it.
Who was I was gonna take it. Why are you not here? Did you get quarantined? What?
Yeah, I got quarantined.
You did? Okay, that's oh gosh, enough. Well, unfortunately, you cannot come and take the test now. That's what it. I mean, you can see my email right now because I'm sharing my screen.
Yeah, I got the same email.
Okay, good. So hopefully that answers most questions. If you are virtual, if you are remote and you are not sick, you need to have somebody come get you around 12:15 is what it says. So, all right. Let's see how well I can write on my board. All right, so you guys have this. It's just I have mine in my it's not going to let me F11 this. I have mine on my Word document and not the Google Doc because it let me write on it earlier. So we're going to see if it lets me do this. Yes, you need a periodic table to be able to take the test. We're going to be using periodic tables for the rest of the year. So this first part is I have a copy. Here. I have a copy. The computer's giving me a headache already. Okay, so from a periodic table, we need to find the element barium. BA is number 56, down here on the bottom left. And it wants to, we need to do the common ion form, how many electrons have been lost or gained, how many total electrons it has when it becomes its ion, and then is it a cation or an anion? Okay, so I'm gonna get ink. I think I can only write in black though. I don't think it'll let me change colors. So first of all, what is barium symbol? I just said it. What's barium symbol? Which one's barium? Which element? What symbol?
BA.
There we go, BA. It should let me write in here. Oh, that's not calibrated. Let me fix it. Okay, so now let's see if it lets me do this. So we have BA. I'm just gonna have to learn to write above. It's not all of it. Well, if it's not one thing, it's another thing. All right, BA, right up here. Okay, and then when it has, when it becomes its ion, is it Well, first of all, how many valence electrons does barium have? It's in group 4. 2. Is it going to lose 2, or is it going to gain 6? Lose 2. So is it going to become positive or negative by that much? Positive. So barium is going to be positive 2. We just said it had to lose 2 electrons. So if it lost 2, it originally has 56. When it becomes an ion, how many does it have? It originally has 56. It's going to have 54. I'm having to write above where the space is. So if they start jumbling up on top of each other, I do apologize. If it's a positive charge, is it a cation ion? Is it a cation ion or an anion? Positive charge is which side? Cation. And I've said this a couple different ways. Y'all, the T is a positive symbol. If it's a positively charged ion, it is a cation, not a cation, a cation. If they're negatively charged, then those are anions. This is going to get fun if I can't write in the right spot. What is chlorine's symbol? Cl. You know what I'm going to do? I'm going to erase. Does anybody still need that section? I'm going to erase it so I'm not writing on top of stuff. As I know full well, if I don't, I'm going to write on top of everything. Cl is the symbol for chlorine. What group is chlorine in? Which group is this? It's in group 7. You're counting from left to right, skipping the middle part. If it has 7 valence electrons, is it going to want to lose at 7 or gain 1? It is going to gain 1. So is it going to be positive or negative 1 if it gains an electron? Negative. I do write ones. Some teachers say if there's 1, you just do a plus or a minus. I was taught to write the 1. I don't think both of them are acceptable. So if it has, if I find chlorine, its atomic number 17. The neutral atom has 17, but the ion has how many? 18. And if it's negative, is it a cation or an anion? Oh, anions. This is really hard because I'm writing not where it's going. I wonder why it's doing that, even though I calibrated it. Who knows? At least it's letting me write. I seriously think it's just going to be easiest to erase this. Silver's a little different. And no, you're supposed to be an eraser, not me. There. Silver is not a group A element. Silver is in the middle. And this is going to tell me if you actually put the stuff in your block like I told you to. If you put on here, you put a charge in silver's box. Silver's formula, its letter, its abbreviation is Ag. Does anybody have the number actually put in their box for silver? Like I told you to do?
+1.
It's +1. If you did not do this on your periodic table, in silver's box, you should have a +1. And then to the right of it, zinc and cadmium, Zn and Cd, they both get a +2. They're the only 3 things that should have their oxidation charge in this part where we put those orange lines. Because all the other ones have more than one type. So if it's a +1, when it's an ion, did it gain or did it lose an electron to become that way? It lost 1. It's positive. I know it's a cation. And then if its atomic number is 47, how many electrons does an ion have? 46. There are questions like this on the test. I am recording this. I'll throw this on the on Canvas. I'm just hoping we can get through the whole thing. If we can't get through the whole thing, then That is on y'all. If Miss Humphrey, if she posts her key, I will link it. Well, come on now. Stop that. There we go. At least it's sort of working. I'm like, no, or it's a psychotic. Let me scroll this down. Oh, this is gonna be fun. All right, so magnesium. If it's in group 2, how many valence electrons does magnesium have? It has 2. So how many dots am I gonna put around magnesium? 2. This is gonna be fun. All right, so we got magnesium, and I have one here, and I have one here. Ah, it's not too bad, considering I can't write where I want to. Is it going to lose its 2, or is it going to gain 6? It's going to lose 2. It's going to end up having a positive 2 charge. We are going to lose 2. So what is its ion going to look like? It's not going to have any dots. The way that I draw them, I don't go to the interior shell. But I have to put something on the upper right-hand corner. What goes on the upper right-hand corner for the ion? +2. Most teachers are going to have you put the ion in brackets and then that positive or negative charge outside. Atoms don't get brackets. Neutral atoms don't get brackets. Ions get brackets. And then the charge goes outside, always on the upper right. Okay, argon. It's in group 8. How many valence electrons does it have? 8. So how many dots does it get? This is going to be fun. we're going to have 1, 2, 3, 4, 5, 6, 7. Yeah, I know I didn't do it in the right order because I wanted to try. That's supposed to be an R, not a F. Whatever that looks like. Is it going to gain or lose electrons? No. So is it going to have a charge?
No.
No. So does it have an ion symbol? No, it's just AR. And it doesn't get brackets because it is an element. It is a neutral element this way.
Oh, we have to.
If it's an ion, you are supposed to. Silicon is in group 4. How many valence electrons does it have? 4. So it's Si, 1 on each side. What is it going to do with its electrons? Both. Both. So, and I don't know if I can fit all of this in here. It's going to gain or lose 4. So what would its charge be? No. Could be two different things. Positive or negative 4. And yes, I'm not going to put brackets around it because I know I'm going to run out of room, but your silicon could be a positive or a negative 4 charge. You are more than welcome to put brackets around it. I'm ready to get past the Lewis dots and get into building and naming, which in my opinion, this is probably not going to let me erase right away, but we'll find out. Come on, go away. I wish the clear all would work on here, but it doesn't. Okay, on here, I took off ionic radius. But I know that I can't draw, I don't have enough room to draw on the top, so I'm gonna draw on the bottom. There are 4 trends. As we go from left to right, what happens to the size of a radius as you go from left to right? Does it get bigger or smaller? Get smaller. So I'm just gonna write radii, because it's for both of them. It's both atom and ion. They're both radius. What happens to the energy and the electronegativity as you go left to right? Is it bigger or smaller? It gets bigger. So both the ion energy and the electronegativity, I'm just going to write electroneg, they increase. You should have put these trends on your colored periodic table, and yes, there's questions about this big time. Radius, the atomic and the ionic radius, they both decrease as you go left to right across the periodic table. And as you go down, you have a different trend. As you go down, what happens to the radius? It increases. I'm going to put radius. Ooh. No. Oh yeah, that's not good. That's ugly. Let me try again. Oh. It even shows the eraser, and then when I go to erase it, it's erasing black. You evil board. There we go. I just had to yell at it. Okay, so it's the radius increases, and then the energy, they're going to decrease as you go down. That's electronegativity and ion energy as you go down. They get smaller. We're going to use these to be able to answer the next chain. Yeah, it won't let me do clear ink. Can I delete it this way? Yes. Oh, but I don't want to do that. So annoying. I never thought I wanted chalkboard so bad in my life. We're gonna use that, and yes, you need periodic table. Ooh, I'm missing old school chalkboard right then. Okay. Now, I don't think I can highlight with Microsoft Ink. Oh, I can. Okay. Highlight the largest atom in each set. Okay, so we need to figure out which trend we're talking about first. So we're taking a look at calcium, beryllium, radium, and strontium. And on the periodic table, you've got calcium, beryllium, we've got strontium, and we've got radium. So this is the up and down trend. And this is talking about the size, the radius. So as we go down, they get bigger. We're not going side to side. So whoever's on the top is going to be the smallest, and whoever's on the bottom is going to be the biggest. And the one that was on the bottom that was listed in this set was radium. So that is going to be my biggest in that one. And then if I go back to my ink and I make a pen, we're going to box in the smallest, which would be the top one, and the one that's in here that's done that, I'm just going to circle it. It's going to be beryllium. That would be the smallest. The hardest part with trends is just figuring out, is it talking this way? Is it talking this way? And then sodium, aluminum, magnesium, and argon. So sodium is here, magnesium, argon is way over here. And what was the other one? Aluminum? Aluminum. So we've got one going side to side, and as you go from left to right, they get smaller. So whoever's furthest to the right is going to be the smallest, and that's going to be argon. That's going to be your smallest, and then if I go back and highlight, whoever's on the left is going to be the biggest, which is going to be sodium. It's just a matter of figuring out which one. Potassium, hydrogen, lithium, francium. We're going up and down. Hydrogen is the one on the top. So it's going to be the biggest. No, I just did that wrong. Biggest is on the bottom. Biggest is francium. Smallest is going to be hydrogen. That would be your smallest. And then lithium, potassium, no, phosphorus. Lithium, phosphorus, that's to the right. Vanadium is one down. And radium is, okay, so my biggest one is going to be radium because it's furthest on the bottom. This is all over the board. This is talking about the element that is here, here, here. What was the other one? Phosphorus. Okay, here. So this is a combination of the two. The one that's down here will absolutely be the largest. The one that's the furthest to the top, he's going to be the smallest. So lithium is your smallest, and then radium would be your largest. I personally don't like asking questions like that. I like keeping them in the same up and down row or side to side row. Whoever originally made this review was a little bit meaner. Highlight the largest in each set. Now this is different because we never really went over this. With a radius, the reason why we go left to right, they get smaller, even though there's more stuff, is because you have more of an attraction between the opposites. Okay, so as you have more, they sort of squeeze each other down. So which would be larger, a neutral atom or one that has more electrons in it? A neutral atom. That one's pretty easy to understand, but this one, this has a positive ion. So if you have less electrons, there's less of an attraction, and what is the atom going to actually do? If there's the attraction pulls it tight. If there's less of an attraction, what is the atom going to do? It's going to get bigger. So your positive ions would be your largest. I did not see a test question that actually asked that on the test when I went back and looked. Which makes me think that there's a test question like that on the assessment, which I'm not allowed to see yet, if they put that in here. The energy required to remove the electron from an atom. This is called ionization energy, is what this one is called. Let me erase all my scribbles. Okay. And then highlight the atom with the highest first ionization energy. So this is the same thing as the energy. So as you go from left to right, it's going to increase. And as you go from top to bottom, it's going to decrease. Fluorine, chlorine, bromine, and iodine. Let me go down here. Fluorine, bromine, and iodine, up and down. As you go from left to right, ionization energy increases. As you go from top to bottom, it decreases. So of these four, who would have the most ionization energy? Top to bottom, it decreases. Who would be the largest in these four? It says, we're going in up to down route. Where'd it go? Okay. It's in order, but it's first on the top, then below that, and below that, and then below that one. Ionization energy, as you go from left to right, it increases. As you go from top to bottom, it decreases. So the one that has the most energy has to be the one that's on the top. That particular one is fluorine. This is the biggest. And then the one that's on the bottom, which I'm not going to box, I'm going to circle. I don't even want to try to make a box. The one that's on the bottom, which is iodine, is going to be the smallest. Boron, carbon, nitrogen, and oxygen. These are going from left to right. Whoever's furthest to the right would be the largest. Whoever's furthest to the left would be the smallest. So boron would be the smallest. And then oxygen would be the largest. And then the next one I have is sodium, potassium, lithium, and rubidium. So these four, The one that is on the increase, decrease. The one that is on the top would be the biggest, would be lithium. The one that's on the bottom would be the smallest. See, even I have to go back and double check and make sure that I'm right. Rubidium is the one that's on the bottom, so it would be the smallest. The relative attraction for an atom for electrons in a bond. This is called electronegativity. It wants to gain electrons. The most electronegative element on the entire periodic table is fluorine. Remember, group 8 does not count. They're inert. They're not active. Get rid of these scribbles. Highlight the atom with the higher electronegativity, right? Higher. Higher is going to be further to the right, not group 8. Plutonium, radon, all the way to the right, but it's a noble gas. Barium towards the left, and tungsten in the middle. So the furthest to the right that is not a noble gas will be plutonium. This is the most. The furthest to the left, and I didn't choose radon because it's a noble gas. The furthest to the left is going to be barium. Copper, silver, and gold. This is up to down. As we go down, the energy decreases. So copper would have the most. Gold would have the least. And like I said, if you put these trends on your periodic table, it's just a matter of figuring out, are they going this way or are they going this way? Oxygen, sulfur, solarium, and tellurium. This is straight up and down. The one on the top is going to have the most, which is oxygen. The one that's on the bottom is going to have the least, which is tellurium. And like I said, if I build a test, I like to do them that they're all right next to each other and they're in the proper order, either top to the bottom or left to the right. And that way it's easier for you to find them. You're not having to jump all over the periodic table. Oh, one more. 6 is called ionization energy. And then 8 is called electronegativity. Get all these. Take those. Ionic. No, that's right. Okay. Which compound below is ionic? Okay. Remember, metallic bonds are all metals. Ionic bonds are metals and then nonmetals. Covalent bonds are all nonmetals. So which one of those is starting with a metal? 2 of them start with nonmetals and 1 of them starts with a nonmetal. Which one's the nonmetal? I'm sorry, 2 of them start with nonmetals and 1 of them starts with a metal. Which one's the metal? Yep, potassium. That is the ionic bond. These are both covalent bonds. Which type of bond conducts electricity as a solid, specifically a solid? What can we run electricity? What can we run electrical current through? What's inside this that runs electricity to my computer? It's not the insulation on the outside that does it. That's what keeps me from shocking the crap out of myself. What's inside here that runs electricity from that outlet to this computer? Y'all don't know what's inside wires? You said metal. Okay, I didn't hear you. Metallic bonds, they conduct electricity because of what they call the sea of electrons, the free floating electrons that allow the current to flow through it. Now, if I melt an ionic compound, then it will conduct electricity, but that's not in the solid state. Which compound below is covalently bonded? Which one starts with the non-metal? Only one of them does.
D.
B. Yep. If you ever see a prefix, mono, di, tri, tetra, penta, hexa, hepta, sexa, octa, nona, doca, they're going to be covalent. Ionics don't use those. We just haven't gotten into that yet. That's after Thanksgiving break, how to name them. Where on the periodic table do you find elements in the metallic bond? Where are the metals on the periodic table? To the left of the staircase. Oh! No, I just somehow highlighted off into space. I don't know why I did that. Which type of chemical bond shares electrons? Which one? Ionic steal from each other. B, covalent share with each other. In a metallic bond, they're loose. They're able to move. What type of bond creates compounds with high melting and boiling points? I know it's not covalent. They have low melting and boiling points. So do ionics have high melting and boiling points? Yes. But what about metals? Do most metals, yes, I know mercury is a liquid at room temperature, but let's ignore the weird metal mercury. Do most metals take a huge amount of heat to melt them? Yes. And so the right answer here is actually B. If it was just between ionic and covalent, then the answer would be ionic. But they threw metallic in here too. And yes, there are some exceptions. Like gallium, if you put it in your hand, it'll melt. You pour it out on the table, it'll turn back into a solid. But most metals won't do that. All right, let me change this to a pen. For each of the following, use letters as many times as needed. Has delocalized electrons that move freely between metal cations. Is that going to be metallic, ionic, or covalent? Yeah, that's a metallic. This is not easy. I feel like a 6-year-old trying to write with my mouse. Electrical conductor when molten into a liquid. I just told you this. Of the three, when you melt it, can it conduct electricity? Ionic. A bond between metallic elements. Just metals. What would it be? Metallic. Between cations and anions. I. Only nonmetals. Covalent. Which of the three, when it makes a compound, likes to make gases? I'll give you a hint. They're red on the periodic table up there. What are those? There's metals, nonmetals, or metalloids, the chunk of the red ones. Those are nonmetals. That makes a covalent bond. Malleable and ductile means we can hammer it into a thin sheet or we can turn it into a wire. Electrons are transferred forming... Okay, it makes ions. What type is it? Ionic. Uh-oh. Compounds that do not conduct electricity, like ever. Covalent. Draw the Lewis dot structure for calcium chloride. Okay, so you're going to put the calcium in the center. Okay, it's got 2 dots. You're going to put fluorine on the side. I'm sorry, I'm trying to do this with my mouse, and so it looks like a 2-year-old did it.
Wait, so because that's the two on the bottom, can you put two instead? And just two?
Which one are you talking about? This one that I'm doing?
Yeah.
What was your question again?
Because that's like double.
Yeah, because you have 2 chlorines. That's what that means. So this one's going to go here. This one's going to go here. This one's going to have all 8 dots, is going to be -1. This lost both of its electrons, it's +2. And this one over here also gained an electron, so it's -1. So your chlorine would have all 8 dots. Calcium, I personally do not put dots around my metal. I do put the charge on it. But it lost both, so it's going to be +2. This chlorine gained another -1. So -1 and -1 is -2. 2 minus 2 is 0. So the compound itself is neutral. The ions carry the charge. I might be able to get through one of, well, here, I'll let you see that. I did put in the thing. I might be able to get this through one of these covalent Lewis dots. Let's see, which one do we want to do? Oh, or would you rather go through the vocab real quick? Let's do the vocab real quick. Covalent bonds in which the electrons are shared unequally. If they are shared, we just did this yesterday, unequal. You have a positive and a negative region. Which one of those is it? Polar. They are shared equally yesterday. What is that? Non-polar. Nitrogen and oxygen, which atom is least attracted to the shared electrons? Which atom is least attracted to the shared electrons? I'd have to look at this. Oxygen is 3.44, nitrogen is 3.04. So oxygen would want it more. And we only have a couple minutes. So this part, I put this up here on mine. It's not on yours. To do the electronegativity difference, you would find silicon 1.90, sulfur 2.58, and you'd subtract them. I did do this. Let's see, so it's 2.58 minus 1.90. It's supposed to be a 9, which is 0.68. We'd have to look at that chart if it was ionic, if it was nonpolar, or if it was polar. And this one is polar covalent. In fact, and I'll see if I can't get a key done up if Miss Humphrey doesn't do it, and I'll post it to Canvas so you can get the other ones. I may have to draw on it like this, so it may look like a 2-year-old did it. Sorry. Let me pull this up. Stop this. Whoops.